Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem. Minimum characters to add for palindrome. What the problem is saying is we'll be given a string. We want to find the task is to find the minimum characters to be added at the front to make the string palindrome. Okay. So let's see what is a palindrome, right? A palindrome is a string wherein if you read from left to right and right to left, it's the same, right? So for example, ABA from left to right and ABA from right to left, it's the same. So this is called palindrome. Okay. Now, what the problem is saying is we'll be given a string and we want to make it a palindrome, okay, by adding minimum characters at the front. At the front. So, for example, if this is a string, so in order to make the string palindrome, what we'll have to add? We'll have to add here something like this, right? CBABC, right? CBABC at the front. Okay, then only so we need to add CB at the front so that this string becomes palindrome. So how many characters we added here? So we added two characters. So that's what we have to return the number of characters two. Okay, okay. So this is the ask. Okay, okay. Now how can we solve this problem? Let's see something, right? Let's see how can we solve this problem. For example, if there's a string, definitely if it is given this, right? If this is a string, okay. Now, if we add the reverse of this particular string, if we add the reverse, what is the reverse of the string? CBA, right? The reverse of ABC is CBA, right? So if we now once we have this string, right? Once we have the string ABCCBA, okay. Now if we look now, what we need to do is what we need to do is we need to check the LPS basically of this particular string. Now, what is LPS? LPS is nothing but longest prefix suffix. Okay, longest prefix suffix. So we have already seen in yesterday's problem, right? So we had calculated this longest prefix suffix. So in this particular case, what is the longest prefix suffix we have? The longest prefix suffix is A only. For example, so here A and A are matching, right? A and A are matching, right? So that is what is prefix suffix match? The string at the start, from the start, is matching the string at the end. So here, for example, here what is that string? The string is A and A. But if you see, for example, let me write this string again, right? Let me write this string A B C C B A, right? So the character which is matching at the start and at the end, the string which is matching at the start and at the end, it is A and A only. If you look AB, but here it is BA, so it's not the same. It's a mirror, right? It should have been AB. If it was like this, then we could have said that okay, the longest the longest prefix suffix, okay, is 2 for now because there are two characters matching. Okay, but in this case you can have a look. In this case you can have a look that only one character is matching. So we can say for this particular string the LPS is 1. Okay, now the LPS is 1. So now what we can do is, what we can say is, for example, ABC is a string given, right? So if we take the length of this ABC and if we deduct it from the LPS, the longest prefix suffix, which is what? Which is 1 in this case, right? Because only one character is matching, right? So what is the length of the string? The length of the string is 3 minus 1 if we do. Minus 1, right? Minus 1. So in that case we can say we have 2, right? 3 minus 1, 2. So we can say that two characters are needed, right? In order to make this palindrome, in order to make the string palindrome, right? Because if it was this, right, ABC. So I had to add only C and B, right? Only C and B in order to make the string palindrome. So if you see, right? So with this, the length of the string minus the longest prefix suffix, right? If we do that, then we get the answer 2. Okay. So I hope you have got the intuition. I hope you have got the intuition here. Okay. Now let's look into another example. Okay. A B A, right? Now, according to our approach, right? If we add the reverse, what is the reverse of this? What is the reverse of this? It is what? So A we added, right? B A B B A. So this is a complete string. Let me rewrite again. A B A, right? So this is a string. Okay. Now what is the now see, if you have a look, right? If you have a look, this was the original string. This was the original string. A B A B A. This is the original string, right? So if you see, this is already palindrome, right? If you read from left to right and if you read from right to left, it's already a palindrome, right? So the minimum number of characters to be added to this particular string, it should be zero. It should be zero, right? It should be zero, right? So let's look according to our approach. So what we did was we had this original string, we appended the reverse of this, right? The reverse of this. Now let's calculate the LPS for this. So what is LPS? For example, A is matching. Till now we have LPS as 1. AB and BA, they are not matching. Okay, they are not matching. Let's look ahead. ABA and ABA, they are matching. So till now, the LPS is the longest prefix suffix is 3. Okay, then let's see ABAB and BABA, right? They are not matching again. ABAB and BAB are not matching, right? They're not matching. But if we consider this now, ABABA and ABABA. So yes, so this is the longest prefix, which is also matching to the suffix ABA, right? ABA, right? So what we are going to, so what is this longest prefix which is matching the suffix? The longest suffix, it is of size 5, right? It is of size 5. Now, according to a formula, if we take the length of the original string, which is 5, right? And the LPS of this particular string, right? Whatever we have calculated of this particular string LPS, it is 5. So if we deduct LPS from the original string length, then we get 0. So according to this, we need to add 0 characters in order to make the string palindrome, right? Because it is right. Because it is already a palindrome. So we don't need to add any characters. Okay. We don't need to add any characters. So I hope, so this is the intuition behind solving the problem. Just take the length of the string and deduct the LPS from that particular string. Okay. And you will get the answer. Now how to calculate LPS? So we have seen it yesterday only, right? How to calculate LPS. We'll see it quickly again. Okay. So let's consider this particular string. Let's again revise the LPS computation, right? The longest prefix suffix computation. Let's revise it again. Okay. So here, this is the string. This is the given string, right? Now we'll have a equivalent size array, basically. So this is a string I've just represented in the form of array. It looks like array. Okay. So let's say this is a LPS array. And we say that we are going to initialize this first position with 0, saying that if it is only one character, then the LPS, the longest prefix suffix, it is going to be 0. Okay. Okay. Now, what we are going to do is we are going to have J and I variables here, right? J and I variables. So what are we going to do here? For example, now this both are matching, right? The characters at both I and J are matching. So what we are going to do here? So we are going to add J plus 1 here. J plus 1. LPS of I equal to J plus 1 we are going to do, right? So that is J plus 1. That is, we can say that the longest prefix, which is also the suffix, is of size 1. Is of size 1 because is a prefix which is matching the suffix for this particular string. Okay, for this particular string. Now, what if this character match, then we are going to increment both J and I. So J will point here, I will point here. Now, what we are saying here is, so let me also write the code here. For example, what we're going to do, we are going to have first of all int J equal to 0, int I equal to 1, right? And what we are saying is we'll have a while loop while I is less than n. N is the size of this particular string. Okay. And what we are saying is if str dot, for example, let's consider some subscript notation. If it is same, right? Both the characters are same, then in this case, what we are doing, we are incrementing both I and J, right? But if the characters are different, then in that case, what we are doing? In that case, what we are doing is, so if we check here, if J is not equal to 0, then in that case, what we are doing is we are having LPS of J minus 1. I'll explain this why we are doing this, right? Okay. But if J is 0, then what we are simply doing is LPS of I, we are initializing with 0. That is, we are setting 0 and we are incrementing I. So I'll explain this why we are doing this. Okay. So this is a pseudocode for computing LPS. Okay. For computing LPS. Now, coming back to, so these characters A and B, they are not matching. Okay. The characters at I and J, they are not matching. So according to this, so we'll go into this else loop and we're going to check. Okay. J is not equal to 0 because J is already 1, right? J is not equal to. So what are you doing here is J equal to LPS of J minus 1. Okay. So J is 1. right? LPS of 1 minus 1, it is going to give us 0, okay, which is j. J equal to what? LPS of 0. LPS of 0 contains 0, right? So we are going to initialize j here. So just be with me, I'll explain why we are doing this, why we are doing this particular step. Okay, so now here, yeah. So now here I is here, j is here, right? J is here. Again, the characters are not matching. So we are going to go to into else, but here this time j is 0, right? J is 0 this time. So we are going to have this particular thing, right? So what we are saying, LPS of I equal to 0. So we will initialize 0 here and we'll increment I here, because we cannot do this step. We cannot do this step because j is already 0. Okay. So we're going to increment I here. So I will be here, right? I will be here and j is here. So now we are going to compare the characters at both I and j position. Yes, they are same. So what we are saying is, according to this particular formula, yeah. So what we are saying is, for this I plus plus I and plus plus j, when the characters is matching, we also want to do the third step, which is LPS of I equal to j, right? Okay. So here what we did, so j was here. So j plus 1 we want to assign to LPS of I. What is LPS of I here? Here, right? Because what we are saying here is the characters are matching. That is, we have found one character. Okay, we have found the LPS of length 1, okay, which is also prefix and suffix. Okay, prefix and suffix, LPS 1, AA, right? So we are saying j plus 1, j is 0, so 0 plus 1, 1. Okay, now, so when the characters are matched, so we also increment j and we increment I as well. Again, we check here. Now both A and A are matching. So what we do? LPS of I equal to j plus 1. Okay, this is the formula, right? So what we are saying is, for this particular string, okay, for this particular string, the size, the LP size is 2, because there are two characters at the start and two characters at the end, we are matching, right? So j was 1, j was 1, 1 plus 1, 2. So we are writing 2 here, right? Because j was pointing here, j. Now when the characters are matching, so we again we'll increment j and we'll increment r. Sorry, this was, let me take one more. This is A and this is C. Okay, this is A and this is C. So I was here. Now, no impact on whatever we have explained previously. So I was here. Now I will be here. And J is here. Right? J is here. Now there's a mismatch. Now there's a mismatch. So let's write here. Let's write here. So for example, A. Let's consider, maybe we can consider two strings now. So this particular string, A. Okay. And another string is AAB. Okay, AAB, right? So why we're taking two strings and why we are cutting at B only? Because J is pointing here and I is pointing here. J is pointing here, right? J is pointing here. So the characters at both these positions, they didn't match, right? They didn't match. Now, what does LPS say? We don't have to go all together to the zeroth element to start matching again. Okay. So according to this formula, now according to this formula, J is here, right? J is here and I is here. So according to formula, LPS of I, what do we say? Sorry, not this one. So the characters didn't match, right? A and B didn't match, right? So we went here, right? We went here. If J is not equal to 0, so what we are saying here is J equal to LPS of J minus 1. So J is LPS of J minus 1. What is J? J is 2 here. 0, 1, 2, right? J is 2 here, right? J is pointing here. J is pointing here. So what we are saying here is J minus 1, 2 minus 1, 1, right? So J equal to LPS of 1. What is LPS of 1? LPS of 1 is this, right? LPS of 1 is this. So J equal to 1. So J will start from here, right? J will start from here. This is 0, 1 and 2 position. J equal to 1. So J will start from here. Okay. Now why is J starting from here? Because what we are saying is the previous characters was already matched, right? The previous characters already matched. We don't have to start J altogether from 0th position, right? We don't have to start 0th position. So we have started from here, A and A. A and A. We have started. So what we are saying is this was already matched, right? The previous thing was already matched. So let's start from here and here. So we'll again start from here and here, right? So what we are saying is now J is pointing to this particular position, J, and I is already here. So this is matched. Okay. So again, what we are saying here is, when there's a match, so J plus 1, LPS of I equal to J plus 1. So J is at position 1. So 1 plus 1, 2 we are going to say. And then we are going to increment I and J both. I and J both. So J will be here, right? Sorry, J again. Sorry, J will be here at B position and I will be here at this particular position. So again, we say there's a mismatch. Okay. And again, it will go all together here. B will start from here and again we'll compare here. Now it is still a mismatch. Again, then finally we are going to start from J0 and we won't have a match and then hence it is going to be 0 here. Okay. So this is the intuition I had already explained yesterday to compute LPS. Maybe it 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 is a bit difficult, I'll say, but I've tried to make it very easy for you. So this is the intuition behind solving the problem. Okay, if you, I think you'll understand better with code. Okay, you can go through again through the LPS computation code, and you'll get the answer. Okay, so before going to the code, I'll request you to please subscribe to the channel. I've tried to make it very easy for you. So let's quickly code. Okay, so what we are doing first, what you're going to do is we are going to have a reverse, right? Reverse equal to, I've already explained this, new string builder. First, I'll show the Java code followed by C++. Okay, S dot reverse dot toString. Okay, so we have a reverse string, reverse of S. Now, what we're going to do is we're going to have S equal to. So, what we're going to do, we are going to append S plus reverse, right? S plus reverse, and let's assign it back to S. Or maybe we can have a new string, new str. Okay, so S plus reverse. So just between these S plus reverse, they're going to add just a separator. Okay, in order to avoid the confusion, in order to separate the original string with reverse. Okay, it won't harm anything. Okay, it won't harm anything. So yeah, so between the original string and reverse, we are adding the new string. So here is a new string. Okay, here's a new string. Now what we are going to do is we are going to compute LPS first. Compute LPS. Okay, we are going to pass this new string, right? Okay, now this will return what? This will return our LPS array. LPS array. Okay, LPS, compute LPS. LPS, we have a new string. Okay, and then what we're going to do here is let's have n equal to, let's take the size new string dot length, right? Dot length. Okay, and then we are going to have j equal to 0. I will explain this, int I equal to 1 while I is less than n. Okay, now we're going to check if str dot char at new string, sorry, new string dot char at I equal to new string dot char at j. If both are same, then what are we going to do? LPS of I equal to j plus 1, right? J plus 1 and then plus I and plus j, right? Plus j. If it is a match, if it is not a match, if it is a match, we have done this. And if it is not a match, what we do? If j is not equal to 0, then j equal to LPS of j minus 1, right? LPS of j minus 1. Else, else, else LPS of I equal to, there's a mismatch and j is already at 0. So we're going to say j LPS of I equal to 0 and I plus plus we are going to do. Okay, I plus plus we are going to do. I've already explained this. Okay, so here the computation is done. Finally, we are going to return LPS array, right? LPS array. We are going to return. Okay, now we have this. We have written this LPS equal to this. Okay, now simply what we're going to do is return. Let's take the length int n equal to new string dot length, right? And I will explain this s dot length. We are going to deduct the LPS of the new string, LPS of the string from the original string length. Okay, I will explain this, right? So let me compile this. I hope it should compile successfully. Let's see. It's evaluating. Yeah. Our output has not come yet. It's taking a while. Okay, there are some errors. Cannot find LPS. What is that? LPS. Okay, we didn't define the array itself. Funny. Int LPS equal to new int n, right? And also let's initialize this LPS of first position. I've already explained this. Okay, so let's again try to compile. Again, expected output. It's taking a while. Okay, it's compiled successfully. Let's submit it. So I hope you have got the solution. Please don't forget to subscribe to the channel, like the video because a lot of effort goes in solving the problems and creating the videos for you. Okay, thank you so much. So let's quickly see the C++ code as well. Okay, the test cases are passed. They should pass. Okay, so yeah, let's quickly see the C++ code. So here is our, so we are taking this reverse string, this string into the reverse REV string basically. Then we are reversing the string. We are appending the reverse string, right, to the original string along with a separator. We are computing LPS here. So LPS we are taking, right? I've already explained this j equal to 0, I plus 1. If the characters match, then increment the length, right, of j, right, and assign it to LPS of I, right? And yeah, we have seen this basically. So once the LPS is computed, then take the length of the original string, right? Take the length of the original string and deduct the LPS from it, the longest prefix suffix from, okay, the length of the longest prefix suffix from it, okay, and hence it will solve your problem. Okay, please, thanks for watching. Please don't forget to subscribe to the channel. Have a happy, healthy, wealthy, and a great day. Thank you so much.